objective of automation is to transform the map content creation approach to move from the manual process to semi-automated process by leveraging automated detection capabilities. This would help us support increased operational abilities and to meet the project scope in significantly reduced cost. This would be performed through automated coding of attributes via map feature coding called as MFC. How do we do so? Let me explain you through a small example. With technology, currently our digital cameras have a feature called as smile detection, which automatically clicks the photograph of a person when a person smiles. This is only possible because the digital cameras has the capability of identifying the smile on a human face with the use of its inbuilt smile detection software. We are following a similar concept in which we are currently making our system intelligent to identify features, signs, automatically, which is called as feature recognition. In this, signs are detected automatically with minimal manual intervention. This is then followed by manual transcription of unsupported features found in the country, and currently this semi-automation process supports most of the critical attributes. Does it sound interesting? Now, how do we make this possible? Let's understand this right from the scratch. First, AL gets the raw image of signs in the PDF format from the government sources. Now these PDFs are converted into SVG format by the AEL team using the Inkscape tool. These are called as templates. All such signs are created into templates for a particular country. Will this be enough though? Not really. In order to make automation more efficient, we require accurate images of the signs which are presented reality, the ground truth reality. These basic templates and the drive files are now uploaded in the Viper tool and sent to IPC for further processing. Here we start collecting ground truth data, which creates a library of signs. This process is similar to capturing a photograph of a sign through various possible angles and varied distance. This is performed for all drive files provided in a country. According to function class, we drive 1000 to approximately 2500 kilometers for a country to make a library of all possible signs in a country. We then perform variation analysis to identify the variation from the basic templates, which in turn helps the AEL team to decide which additional or new templates need to be created. Let's have a deep dive of how IPC collects the library of signs through the Viper tool. Once all the templates are created and categorized by the AEL team, it then moves to reality capture and processing team for creating algorithms of these templates. This forms a part of the NVT detect software. The software scans through each video frame and detects the sign automatically in the drive file. These are called as detections. Here is how we make the system intelligent. Accuracy of these algorithms is tested by the AEL team by collaborating with the RCP team. The algorithm is tuned multiple times by the AEL until it achieves an accuracy rate of 85 to 95% detection rate for each feature type. This is now an intelligent system to run through the rest of the drive file of a particular country and is deployed on the AWS server, which is Amazon Web Services. This forms as an input to the IPC continuous drive file processing, also called as CDFP projects, where RMC provides the list of prioritized admins along with the list of attribute sets. IPC starts creating composite drive files for these admins to avoid overlap of drives. These files are run through the NVT Detect software, which scans and detects the signs in the drive files. These detections become input to the next process, which is detection review. Here, according to country specs and scope of the project, the detections that are accurate and required are marked as verified in the detection review tool, and the ones which are out of scope and invalid detections are marked as rejected. Once the DR is complete, then all the verified signs will be mapped into the map feature coder called as MFC just by a single click, which is code in MFC. MFC is another intelligent system which has an inbuilt logic and will currently code in a virtual database. In this database, it will check for existence of a sign and also perform automatic coding of the sign. The features which are created in virtual database are now manually checked to confirm the accuracy of the coding and also to code any incorrect coded feature, which is called as MFC snapping. Once the MFC snapping is completed, the unsupported features for automatic detections and misdetections are now manually transcribed using the Viper tool, which is auto-sync to MFC again. Next, these features in MFC are now auto-coded in Atlas by another click, submit to TurboMap. And the features which cannot be coded through TurboMap and through MFC, those fallouts has to be manually coded by the coder in Atlas. Let's have a detailed look over the CDFP process followed at IPC.